Sir, in the last videos, very clearly we have started recursion. So in detail about this recursion, we have seen, okay, almost um, 5 to 6, not 5 to 6 days, almost 9 days we are in recursion. So now today I'm not going to take arrays concept. Okay, so by solving towers of Hanai, I will end this recursion topic. But in future also we are going to use recursive algorithms everywhere. Their arrays related problems will be covered. Okay, right. Sir, let's go for today's session. That is nothing but towers of Hanai. I think, sir, everyone know about towers of Hanai, right? Everyone know about at least some basic idea about this towers of Hanai. You people heard, sir. Maybe in your college days, okay? Maybe in your college days or somewhere, sir, you have used these towers of Hanai. Of course, its implementation is already fixed. Just we have to trace out how it is going to work. Sir, what is mean by towers of Hanai? Okay, what is mean by towers of Hanai? Okay, sir, towers of Hanai is nothing but, sir, it is a problem. It is a problem. Okay, sir, where where we have to, so we have to move the disks. Okay, the disks from, okay, source to destination. We have to move from source to destination like this. We have to, okay, by following the rules, by following the rules. What is a rule number one? What is a rule number one? So at a time only one disk we have to move. Okay, at a time only one disk we have to move. Sir, what is the second rule? What is the second rule? Sir, we have to place, okay, smaller disk on the top of larger disk. This is nothing but what we have. So by following these particular rules, we have to move the disks which are present from source to destination. Now let me take one simple example for you to understand. So consider this is nothing but my tower. Okay, this is nothing but destination tower. Sir, consider, so I want to take, okay, I want to take, sir, this is nothing but the first disk what I have. This is nothing but a second disk what I have. This is nothing but the third disk what I have. Okay, this one I am going to represent it as a first disk, second disk, third disk. Sir, how we have to move the disks? Okay, how we have to move these disks from, this is I called source, right, and this one is a destination, right? We have to move all the disks from source to destination. So after moving, the output what I am expecting, okay, the output what I am expecting is nothing but, sir, all these things should be moved like this. That means, so I can able to say, right, like this. So that means your source should be empty and your destination should be like this after moving all these settings. Sir, at a time, is it possible to move? No, we have to take one temporary. Sir, I will take the process here. Listen carefully. Consider this is a source, okay, and this is a destination. Directly you can't move. Even if you move, what will happen? Sir, in source, so we have third disk is there here, and we have second disk is there here. On the top of this we have first disk. If you move first disk from source to destination directly, next alternative we have to take second disk. So on the top of a smaller disk, we should not take larger disk. So for that, I am going to take one temporary disk. Sir, I can say auxiliary tower, or temporary tower, or I can say helper application. Okay, sir, first we will one to this helper. Okay, or we can move one to the destination. In any style we can take. Okay, sir, let me check. First I am going to move. mm, no, I think better we can. one to destination. Sir, this is the first. Sir, now I am going to move second to here like this. Then I am going to move first to here. Okay, like this we have. Sir, next we can move 3 to here, so that what will happen? This will become empty, and this helper tower is having, sir, two disks like disk 2 and disk 1, and the destination disk is having, sir, third disk. Now what we have to do? Again, you need to move 1 to here. Okay, sir, then we have to move 2 to here. Then we have to move 1 to here. So that what will happen? Sir, source will become empty. So helper application will become empty. And in the destination, sir, we are going to have 3 and we are going to have 2. And here we are going to have first disk. Like this we have to do. Okay, sir, it is nothing but best example for recursion, because, sir, if you have only one disk, easy to solve. Okay, if you have two disks, sir, somewhat difficult, but another one or two instructions you have to take. Okay, sir, but if you have 3 disks or 4 disks, assume if you have 20 disks, sir, is it possible to move these 20 disks by using these 3 towers? Highly impossible. Even you can't imagine. Okay, your brain will become struck. Sir, how you can able to solve these kind of problems? Sir, this is possible by using recursion. Okay, so recursion means what? Dividing the problem. But how internally it is going to take, I will explain step by step. There is standard formula is there. You have to remember that formula. Okay, only 2 lines of code. With that we can solve this. So first we will implement the program. Then by taking the number of disks, I will explain one by one. Can you please confirm, is this problem statement, is it clear for everyone? Right, good. Now I will go with the example, sir. First, let me save this. Right. Sir, I will take the program directly. I will take the program directly. Sir, here we have test program is there. Okay, let me remove all these things. Okay. So I am going to read the number of disks. So enter, so number of disks. Okay. Sir, we are going to read the value. Directly I am going to call demo dot, sir, towers of, okay, towers of Hanai. Okay, towers of Hanai. Like this I am taking. Sir, what about the parameters? Sir, this towers of Hanai is going to take 3 parameters, sir. Sorry, 4 parameters. First one is nothing but the number of disks. Second one is nothing but the source. Third one is nothing but, sir, helper. Okay, helper, or we can say temporary tower. The last one is nothing but destination tower. Like this we are going to pass. So in demo class, we have to write static void. It is not going to return anything. Okay, sir, towers of Hanai. So integer number of disks. Sir, string source I am taking. Sir, string helper I am taking. Okay, sir, string destination I am taking. Like this I want to take. Sir, the code is simple, not that much big. Okay, sir, now here, I don't want to take this source helper something like this. I want to give names for the towers. Like if you have this as a source tower, I will give it as yes. Sir, if you have helper tower, H. If you have destination tower, P. Like this I want to provide. Okay, sir, now let me give these names. Source as yes. So this helper as H. So destination tower, I am going to rename it as a D. Like this I have. Sir, first we will solve for the first case. What is the first case? Was if n is equal to 1. That means the number of disks are 1. Sir, what you are doing? I think we know the solution, right? What is the solution? Sir, we are going to move the disk. Okay, we are going to move the disk from. Okay, we are going to move the disk plus n. Sir, from where, sir? From source, right? Source variable is available in S, from source to, sir, destination. That's all. We are not required to take any help, just a return. Sir, here recursion is not invoked because, so just we are going to check when n is equal to 1, then only this application will work. Let me run this program and see how it is going to execute. So Java C, I'm taking test.java. Sir, the code compiles fine. Java space test I'm taking. Enter number of disks. Sir, if you give any other value other than 1, it won't work properly. But if you provide 1, sir, it is going to move the disk 1 from source to destination. A simple example. Okay. When the value of n is equal to 1, that is if the number of disks are 1, how it is going to work? I think you got very clear clarity, sir. Okay. Sir, else if the number of disks are not, what will happen? I think no need to take else, directly I will. There are 3 steps are there. Okay, these are the 3 standard formulas you have to remember. We have to call towers of an eye for left side. We have to call towers of an eye for right side traces, and we need to print system.out.println of, sir, here we have to, better I will take this same so. Okay, sir, we have to move the disks. Okay, we have to move the disks from source to destination. But here what arguments we have to pass? Sir, if n is equal to 2, that means we are calling for 2 disks, then n value is not equal to 1. We are going to get the solution for 1 disk. We are going to get the solution for 1 disk, and we are going to make a movement like this. That is the concept. Sir, here I have to take n minus 1, and here also we have to take n minus 1. Sir, the only thing that you have to remember is nothing but this one, sir. Previously, what is the argument that we have? Source, helper, destination. That argument you have to change here. Source will be there as it is. Destination you have to take first, and at last helper. Okay, sir, now what is the last one? Sir, we have to take a helper. Okay, from helper we have to move to source, and at last we have to take destination. Sir, beginning should be source, ending should be destination. Meanwhile, I'm going to move from destination to helper, helper to source. Like that I can make a movement. These 2 formulas you have to remember, sir. There is no option. Okay, now first we will run whether it is going to work or not. Sir, first we will check really is it happening or not. Sir, now if you are giving 1, it is going to move from source to destination. Just I will take 2, sir. Okay, now you can able to see with the help of a small diagram I will explain. Consider this is nothing but a source tower, and this is nothing but a helper tower, and this one is nothing but a destination tower. So here I have 2 disks are there. So consider this is nothing but a second disk, and this is nothing but first disk. Sir, what is the first instruction that we got? Move the disk 1 from source to helper. We have to move the disk 1 from source to helper, so that that one will be moved here. Sir, here we have only. Now what we have to do? Sir, move to second disk from source to destination. We have to move from source to destination. Now here you will get. Sir, what is the next one? Move disk 1 from, sir, helper to destination. This disk 1 already there in helper, right? We have to. This is nothing but our requirement. Sir, okay. Just a simple logic, sir. Beyond that, nothing. Sir, will it works for 6 disks? Yes. Sir, how many traces we have? It is very difficult even to understand this one, but definitely it will work. Okay, sir, is it possible to provide for 10 disks? Yes, happily it will work. Sir, is it possible for 20? Yes, happily it will work. But it takes some large amount of time, because 20 disks, 3 towers means a big process, right? We have to follow those 2 rules, and we have to follow step by step means it takes more time, sir. Okay, maybe you can't expect how many moves will be there. Okay, this is nothing but what we have. Okay, yeah, I will explain everything as a drawing, please wait. Okay, right. So one person is asking, Ajit Kumar, is the storage will impact? Sir, storage won't be impacted because that's why we are choosing this recursion. See, in the recursion internally stack will be maintained, right? That stack will take care. Okay, up to stack is full it will work. So once if the stack is full, then runtime exception we will get, saying you are giving huge number of disks, maybe it takes some time, or my stack capacity is not going to be sufficient. Sir, for the programmer point of view only, we are going to execute. But once if this application entered into some web servers or any EJB servers like that, there we have an option to increase the capacity of stack also. Okay, there we have all the sufficient things are there that we can do. Okay, sir, it is a stop finite number of steps. So you can't trace also this one, sir, right? It will become very difficult or not? Yes. Okay, sir, don't worry. I will explain this algorithm by taking all the disks, maybe up to 3 I will take, and R4 I will take, and I will explain. Okay, sir, I think this program is very clear for you people, guys. Can you please confirm, sir, do you have any doubts in this code? Sir, don't worry about this execution. I will explain one by one. By taking a neat diagram, I will explain. Clear up to this? Sir, I request everyone to please respond. Now, yeah, I will explain, Chaitanya. Yeah, we can do that. We can do that. So Java C test.java. So we are going to calculate a time complexity for this. Okay, in future, there you can calculate how many times it is going to run. Sir, I think if you are giving one disk, I think no need to explain this test case because only one disk is there, right? So no need to concentrate. Suppose if I am giving two disks, I think just now I explained this is also not required, right? I will explain for 3 digits, I mean 3 disks. Sir, what will happen if I'm giving 3 disks like this I'm getting? First, I want to explain how it is going to work. So we are concentrating only on these instructions, right? Let me take, these are the instructions what we have. These are the instructions what we have. Okay. Here, just for our convenient purpose, I'm going to reduce the number of instructions. Please try to understand. I'm going to take SOP. Okay. Sir, we have to move disk from, okay, move disk from source to destination, and this is the base condition, and here we are going to call, so SOP of something like this. Yes, sir, now we will take, okay, we will take some example and then we will understand how it is going to work. Listen carefully, guys. So much of confusion will be there. Please try to understand. Sir, what is the value of n I am giving? The value of n I am giving as a 3. That means how many disks will be there? 3 disks. Listen carefully. Listen carefully. Sir, listen carefully. Don't write anything. Okay, please wait. Sir, here, first I will solve this according to the algorithm. N is equal to 1. No, it is not 1. Then towers of Hanai of, sir, when n is equal to 3, how the method call is going to takes place? Okay, 2 times it is going to call. This is the first time, this is the second time. What is the first time? N minus 1. Okay, that means 3 minus 1, which will become 2. Sir, in this method call, sir, how you are going to pass the values? First, we are going to pass source, and then we are going to pass a helper, and then we are going to pass a destination. This is the order, right? When we are calling, okay, when we are calling, sir, we are going to pass a source, helper, and then destination like this. we have called. Sir, now here source. Sir, is the source is as it is available or not? Yes, that's why source position is not going to be changed. Now, second position is nothing but a destination. Sir, what is the destination here? D, right? That we have to take here. Sir, next one is nothing but a helper. Helper is nothing but this one. So this is this method call. Sir, forget about this. Sir, what about this method call? So n minus 1, 3 minus 1 will become 2. Then helper first we have to take. Okay, helper first we have to take. Sir, which is the helper here? Middle one, right? So helper I am taking. Comma. Source we have to take. Source is nothing but yes. Destination we have to take, which is nothing but D. So when n is equal to 2, the solution of this one plus the solution of this one, and here one small instruction is there, that this instruction is nothing but we have to move from source to destination. So I want to copy paste output also for this purpose. Okay, just give me a second. I copy paste. Like this we have. Okay, now sir, see here. Sir, what is this? What is this one we got? What is the middle one? Sir, we are going to move the disk. What is that disk? N. N is nothing but 3. We are moving the disk 3 from source to destination. We are moving the disk 3 from source to destination. This is one process. Sir, middle half this one, next half this one. In the middle, it is going to work. But just for your understanding purpose, I am telling this in the middle. But what will happen? It will execute one more time. It will execute one more time. And middle, we are going to have instructions. This one is the first solution, second solution, okay, third solution, then fourth solution, fifth solution, sixth solution, seventh solution. Like this, we will have. Okay, so please confirm just up to this first trace. Is it clear for everyone? Please confirm. Up to this first trace. Is it clear for everyone? Please confirm. Then I will change the color. I will go with the next trace. Right, sir. Good, good, good. Now, sir, what is the next one that I'm going to take here is I will change the color. Sir, now this 2 is again a recursion or not? Yes, one more time it will execute. Sir, is n is equal to 1? No. Then what will happen? Sir, n minus 1. N minus 1 means 2 minus 1, 1. First, we have to take source. Sir, in this, which is a source? Listen carefully. This one will become source. This one will become helper. And this one will become destination according to rule. Source, helper, destination. Remember this. So, 1 comma, we have to take a destination. What is the destination here? Helper, right? Okay. Sir, 1 minute. One source is there. Source is nothing but yes only. Okay, next destination is what here? Helper. Helper will become destination. Sir, then we have to take a helper. Helper will become D here. Like this we have first phase. Then here what will happen? Sir, 2 minus 1, 1. One disk. Sir, helper. Helper is what is a helper here? Destination D, comma. Next one is a source. What is a source here? D. Sir, yes. And sir, destination. Destination is nothing but a helper. Like this we have. Sir, meanwhile, one instruction will execute. What is that instruction? Have you observed? We have to move, okay, sir, we have to move disk N, that is disk 2, sir, from source to destination. In this, which is the source? Yes, right. Which is the destination? H. Sir, we are going to move the disk 2 from source to helper. Move disk 2 from source to helper. Is it there or not? Yes. Now, since n is equal to 1, a recursive call won't be happened. Sir, when n is equal to 1, move the disk 1 from source to destination. Here, what is the source? Here, what is the source? Yes, right. What is the destination? D. Sir, disk 1 will be moved from source to destination. Sir, is this instruction is satisfied or not? Yes. Sir, after this, this one. Sir, after this, so this one. What is this one? N is equal to 1. Sir, here we are going to move the disk 1 from, sir, where? From source to, sorry, from source to destination. Here source is what? This one is source, helper, destination. Source is nothing but a destination. Move the disk from, sir, destination to, sir, helper. Sir, which is this one? Like this, first half of got solved. This is the first solution. This is the second step. This is the third step. And this is the fourth step. Sir, I think first half we completed, sir. Okay. Sir, please confirm. Up to this, do you have any doubts, friends? Requesting everyone to please respond. Clear? Right, sir. Sir, now I'm going to change the color. Okay, I'm going to change the color. I will go with the rest of the execution. Yeah, in order only. Correct, Ishta. You people are remembering all these terms. Very good. Happy to see. Yes. Now listen carefully. Okay, now listen carefully. Sir, here 2 comma h comma, this part is there, right? Sir, again here in this case, the value of n is nothing but 2, 2 minus 1. That is nothing but 1. Then what we have to take source. In this source will become, so helper. Next, sir, what is the next one? Destination. Destination is nothing but the same t only. And sir, what about next one? Helper. Helper will become source. Sir, what about here? Here also we are going to get 1 comma helper. Helper is nothing but what? Source. So comma source will become what? H. Sir, next one, last one is nothing but t. Like this we have. Okay. Sir, what about 1 comma h comma d comma? Yes. That means n is equal to 1. We have to move the disk from source to destination. Disk is 1. Sir, source is nothing but a helper. Destination is nothing but yes. Right? 1 disk from H to S. Right. Next, in the middle, what instruction it is going to execute? Sir, source to destination, we have to move n. N is nothing but 2. We have to move 2 from source to destination. Here, source is H, destination is D, H to D. So, what is the disk number? Disk number 2. Sir, is it moving or not? Yes. Sir, what about this one? Sir, last one. We have to move disk 1 from, sir, which location to which location? Source to destination. Sir, source is nothing but yes. Destination is nothing but D. Sir, we completed second half also. Like this, we are going to get. Sir, I think when the value of n is equal to 3, n is equal to 3, sir, how it is going to work? I think you got very clear clarity, sir. Please confirm. Do you have any doubts up to this? Please explain the sequence in which the two recursive call will occur. See, already we have learned so much of content from the recursion. We are at ending. At ending, you should not ask these kind of questions. Listen carefully. So n is equal to 3. Whenever you are passing the value of n is equal to 3, is it equal to 1? No. Then n minus 1. This one is a function call. Okay, sorry. So this one is a function call. This one is a function call. Okay. So this function call, again, it will invoke recursive, not this one. This one will later it will execute. Again, this one is going to invoke this one. Okay. So this is the first call we are going to get. This is the second call. This is the third call. And this is the fourth call. So this is the fifth call. This is the sixth call. And this is the seventh call, which is going to execute. How many steps are there? 7 steps. Sir, there is a formula also. Sir, 2 cube minus 1. 2 power n minus 1. Time complexity. So when n is equal to 3, sir, 2 cube minus 1. 8 minus 1. 7 steps. When n is equal to 2, sir, 2 square minus 1. That is only 3 steps. I think if you observe here, so we got output only in 3 steps. Okay. So when n is equal to 1, sir, 2 power 1 minus 1, 2 minus 1, 1 step. Sir, if n is equal to 4, 2 power 4 minus 1. 2 power 4 means what? 16, right? 16, correct only, right? 16 minus 1, 15 steps will be there. Okay, like that. No. We have seen so many situations where two recursive calls are going to work. I think so. Sir, we have seen, right? Anyone? Vishal, I told already, we will discuss that later. Sir, is there any program where two recursive calls are coming? I think we have that situation now. Yeah, correct. Fibonacci sequence. So there also, I think I explained with the help of diagram. Please cross check once, sir. Okay. Yeah, this one you can able to see. Like this, two recursive calls are coming. Okay. Please cross check once. Okay. Right. Sir, clear up to this? Please confirm, everyone. Clear up to this? Right, sir. Sir, now for three calls, okay. Sir, what about four? What about four? Sir, how to invoke for four? How to invoke for four? Sir, very simple. Listen carefully. Listen carefully. Sir, when n is equal to 4, what will happen? First time, the recursive call, what we are going to get here is, sir, n is equal to 4. Source, comma, destination, comma, helper. Okay. Sir, source, comma, sorry, 3. Source, comma, destination, comma, helper. Right? Sir, some other execution will be there. And here, 3 is nothing but number of disks, comma. Sir, here what we have to take? Helper. Sir, in this, so consider source, comma, helper, comma, destination. Okay. Sir, in this, what we have to do? First helper we have to take. That is nothing but h. Okay. Sir, then after that we have to take source. Source is nothing but yes. Sir, then we have to take destination. Destination will become t. Now, please listen carefully. Please listen carefully. Whatever diagram we have taken here. Okay. So whatever diagram we have taken here, same diagram will be repeated here. This one. Okay. Sir, again, this part is going to be repeated. Okay. Now, sir, here, how many steps we got, sir? Have you observed? Sir, here, I think 7 steps we got. Okay, 7 steps we got. Sir, here, how many steps we got? I think 7. Sir, total 14 steps you are going to get. Not 14. 14 plus this one step is there, right? Sir, total 15 steps you are going to get. Is it correct? Sir, 2 power 4 minus 1, 16 minus 1, 15 steps. But don't execute as it is, because sir, it is not a direct. See, when n is equal to 3, source, helper, destination is there, then corresponding. But here, source, helper, destination, here we have. When you substituting, this s is the same. Sir, this h you have to replace with d. This d we have to replace with h, and then you have to solve appropriately. Are you getting my point? So try to trace out by yourself. Try to take a white paper. On the top, take n is equal to 4. So these three calls, same thing. Whatever we have done, same algorithm. Only thing is nothing but the positions you have to change. Okay. Sir, when n is equal to 5, what will happen? Sir, 2 power 5 minus 1. What is the 2 power 5 value? 32, right? Correct only, right? 32. Yes, 32 minus 1. That means how many steps? 31. That means when n is equal to 5, you are going to get n is equal to 4. N is equal to 4. And here meanwhile one call. Okay. Sir, n is equal to 4 means how many steps we have completed? Just now we have seen 15 steps. Okay. Sir, here 15 steps plus 1. Total 32 steps. 31 steps you are going to get. Are you getting my point or not? Okay. So, sir, here first calling is completed, then only SOP last statement method will be completed. Yes, sir. See, when n is equal to 1, then only it will execute. It is a recursive method. Don't get confused. Just keep it in mind. So, first one is nothing but until n is equal to 1, it's keep on calling. When n is equal to 1, this movement will be done. And middle, whenever you are calling recursive, so left part, right part will be there. In the middle, we are going to get this instruction. But this instruction immediately it won't happen. After execution of left part and right part, meanwhile it will be taken. Clear? Right, sir. So first step, what we have to do is you have to take a paper and pen. Okay, you have to take a paper and pen. Okay, so what we have to do, sir, first you need to write. First step is nothing but, sir, you have to write recursive method. We have to write recursive method with the base case. Okay, sir, what is the second one? Take n is equal to 1 in a new paper. In a new paper, okay, and solve. Okay, next we have to take n is equal to 2. So in a new paper, try to solve. Sir, n is equal to 3. Take a new paper and solve. Sir, while solving, keep this recursive method and you can practice. So n is equal to 4 and then take a new paper and practice. Sir, if you got full-fledged interest, try to solve for n is equal to 4 also. Okay, if you solve like this, then you will get the complete concept of what is happening here, right? Clear, friends? And check whether you are getting the proper answer or not from this. Okay, so now I am going to copy paste output for sir 4 and 5 also. Let me check. Sir, for 4 these many steps are there. Okay, sir, for 5 these many steps will be there. Okay, right, sir. So this is nothing but what is mean by towers of an eye. So with this, I am going to wind up today's session. At the same time, recursion. Okay, so recursion. So from tomorrow, we are going to start a new topic called arrays. Arrays we are going to explore. Okay. Sir, sorry to inform you that the Python 3 o'clock batch got postponed, sir. Okay. So that new batch, 3 p.m. batch is there, right? Sir, it will be started from Monday. A small issue is there. So that's why we have shifted that batch. Okay. Uh, Python 1.5 hour batch, 1.5 hour class, sir. Yes, Ansari, are you okay? Now at least you got some idea or not? Yes, right. Fine, sir. So I will upload the running notes and images also within few minutes. You can practice. Okay. Rashmi, what is that? You are talking about 3 p.m. batch? Right. So thank you, sir. We will meet for the continuation tomorrow with a fresh concept. Sir, two people have sent yesterday regarding this WhatsApp group. So let me check today. Remaining people, please send a message to me on WhatsApp so that I will add you on the. Okay. Already some people have sent a message. See, you need to send the message. Okay. I can't able to add until I save your contact. So I have already shared my number 7386237319. The people already sent some messages. I will add. Okay. Yesterday, one or two members are already shared their details. Yeah, so 7386237319. Yesterday, two members shared their details. I have added. Can you please cross check? Yeah. So I will add you. I will add you everyone. Don't worry. Okay. Right, sir. So thank you. See you tomorrow.